In this video, we're going to be solving systems using the elimination method. One of our first things that we need to know how to do is understand what would eliminate a term in the first place. Like, how would I eliminate a 3x? Hopefully you realize that we would use what's called the additive inverse, negative 3x. How would I eliminate a negative 7y? You would want it to have a positive 7y. 12b squared, negative 12b squared. Negative 29r, positive 29r. Negative 14, positive 14. Now the reason these will eliminate is because if I would add these two terms together, I would always get a 0 for every one of those. So with systems, we are hopeful that we will find this relationship for either our x values or our x terms or our y terms. We will find out that that's not always the case. And in those situations, we will need to create that relationship. But let's go ahead and look at this one on the next page. Since a positive 8y and a negative 8y, when combined, would eliminate, I'm actually just going to add my like terms downward, and I'm going to have a new equation. So if we add a negative 2x and a negative 3x, you'll get negative 5x. If we add the 8y and the negative 8y, as discussed, we will already realize we're going to get a 0y. If we add the 16 and the 4, we will get a 20. Now, because 0y is actually nothing, I have a new equation that just says negative 5x equals 20. And this is a simple one-step equation to solve. To get x by itself, divide by negative 5, and we will have discovered that x equals negative 4. Now that I know my x value, I'm going to pick one of these equations, whichever one I think looks easier to use, and I'm going to substitute negative 4 in for the x. I'm just going to use the top equation. So now it's going to say negative 2, but instead of x, it's going to say negative 4 plus 8y equals 16. This is a one-variable equation, and hopefully you feel really comfortable in solving this. If not, you might want to practice that to get better at this whole process. You get an 8 plus 8y equals 16. Subtract the 8. You'll get 8y equals 8. Divide by 8 on both sides to get that y equals 1. Now we know the x value, we know the y value, we would get negative 4, 1. X variable always goes first. Let's see another one. Always look for that additive inverse relationship. If it exists, then these problems are going to be easier, and you can go ahead and get started. We do see that here with the negative 4y and the positive 4y. So I'm going to add downward. Add downward, you get 5x. Add downward, you get 0y. And add downward, and you get 60. So our new equation is 5x equals 60. If we divide by 5, you'll find that x equals 12. Since we know the x value, pick an equation. I'm going to go with the top one again. We're going to change the x to a 12. Multiply, you get 24. Subtract the 24 from both sides to isolate your y term here. You'll get negative 4y equals negative 12. Then isolate the y by dividing by negative 4, and you'll get y equals 3. We know the x value, which is 12. We know the y value, which is 3. If I plug it into the top equation and the bottom equation, it would satisfy both of those equations. That's what a solution to a system is. Let's look at another one here. I'm going to go ahead and let you try this one on your own. You can pause this video and then try it, unpause the video, and my work will show up and we can see how it compares. Hopefully you noticed that the x terms were additive inverses, and so you could go ahead and get started on this problem. You cancel those out, you get this new equation, and solve, you'll find y equals -3. I chose to plug -3 into the bottom equation to give us practice with this little negative situation. The negative exists there already, but my y value is also negative. So it's like I have a double negative, which does become a positive. So we solve that one. We find x is 1, y is -3. Put the x value first. That is your solution. In this instance, you'll notice that we have a pretty close to additive inverses relationship. We have a 6x and a 6x, but we really would like for that to be a 6x and a -6x. So what we're going to do is we're going to use the multiplication of -1 to fix that. Essentially, when you multiply by -1, the only thing that changes is the sign. And this is something we're allowed to do because we're multiplying the entire equation by the same value. So we're keeping everything equal. So I'm going to multiply this entire equation by -1. You can notate it this way, or you can put parentheses around it and make it look like distribution. I kind of like that better, actually. So if we distribute the -1, we're going to get -6x, -5y, and equals -17. After you've done this a few times, you probably would just be able to, change that in your mind and write it down. But now we have the additive inverses that I wanted. If I add downward, I'm going to get 0x. If I continue with this, I'm going to get a +3y, and I'm also going to get a +3 on the right side. So my new equation is 3y equals 3. If we divide, we're going to get y equals 1. Take this, plug it into one of your original equations. I'm going to use the bottom one. So it's 6x plus 5, but instead of y, I'm going to use a 1, then equals a 17. So I take this value and I substitute it right there into the bottom equation. This is the bottom equation, in case you were wondering. And we solve. 6x, this will be a 5, 17. Subtract the 5. 6x equals 12. And when you divide, you get x equals 2. Your ordered pair, x goes first, then your y. 2, 1 is the solution to the system. I'm going to let you go ahead and try this one on your own. Same thing, pause the video, come back to us and see how you've done. Hopefully you noticed that if you would take either one of these equations and multiply it by -1, you would wind up with your y variables having additive inverses and would cancel out. So doing that, we solved for x is -2, and then I plugged it into the top equation for the x and was able to find that y is 10. Let's go to a new page. So you've seen from the last one that we can manipulate our equations to have additive inverses for either the x or the y's. This is very similar to the process in finding a common denominator. So I'm bringing it up now to get us to practice this. If I were trying to find a 4 and a 5 and make them a common number, I would use a 20. So you might be thinking, oh, you just multiply them together. That would find us a common multiple, but it won't always be the least common. And preferably we want smaller numbers to work with. So for example, if I multiply these together, I would get a 75, but the least common multiple is actually just 15 itself. So that would be the better number to use. 3 and 2, 6, 7 and 2, 14, 8 and 4, 8, 5 and 10, 10, 6 and 3, 6, 2 and 8, 8, 8 and 32, 32. If you are good at that, it's going to make this next process a lot easier. If you're struggling with that, that's something else you might want to practice to help you out. A calculator can be helpful if you're unaware of how to find those multiples. So here's what we're going to do. We're going to look at our values, our coefficients of our x's, and we're kind of going to think about what number they would match up at. And that would be here a 40. And for the y's, it would just be a 6. So since the 6 is significantly lower than the 40, I'm going to eliminate our y variable. And so I'm going to write down what I call our target numbers. That means I want this one, well, it is a -6. So I'm just going to leave that one as a -6. And I want the other one to become a +6. So since the first equation, I don't need to change anything. I'm just going to multiply that top equation by 1. In the second equation, I would like to change this -1 to a +6. So I'm going to need to multiply by a -6. And right now we're doing nothing but planning for the changes that we need to make in the future here. Once again, 4 and 3, that would match up at a 12. 5 and 4, they would match up at a 20. Well, I'm going to go ahead and eliminate our x's then, because I'd rather change this one to a 12 and make sure that this one then is its additive inverse, which is a -12. Taking a 4 to get a 12, you'd multiply by 3. Taking a 3 to get a -12, you'd multiply by -4. Here we have 2x and x, and that's a 1. So they would match up at a 2, and these two numbers would match up at a 21. So once again, I'm going to eliminate the x, just because it's going to be easier for me. I would like for this one to be a 2, and I'd like for the other one to be a -2. Well, the first one needs no change, so multiply by 1. The second one needs to change a 1 to a -2, so we would multiply by -2. And in our last example, the x terms would cancel out at 15. The y terms would cancel out at 6. So I'm going to go with the y's. I want this one to be a 6, and I want this one to be a -6. If I multiply this 2 times a 3, I would get 6. And if I multiply -3 times just a 2, you would get a -6. Since I didn't need to change either of their signs on this example, I didn't have to use a negative. That's how you get your sign to change. You multiply by a negative, as we experienced on the previous examples. Okay, so let's look at some where we have to change some things here. So look at the x's. Those would cancel out at a 9. These would cancel out at a 20. This one already says -9. And this one already says, or this one I want to change it to a +9. So I need to think, what would I multiply the first equation by? Well, it already matches up, so I can just multiply it by a 1. The second equation, I'm going to have to change it from a -3 to a 9. So I'm going to multiply by a -3. This time I had to multiply by a negative because I want to change the negative to a positive value. Make these calculations, and you would get -9x, -5y equals 15. And your second equation would be +9x, +12y, and -36. Once you have accomplished this, it will be as simple as the first example that we did with elimination. just add downward because of our additive inverses here. You're going to get 0x. Add this, you'll get 7y. Add this, you'll get negative 21. So our new equation is 7y equals negative 21. Divide and you'll get y equals negative 3. Now that we have y equals negative 3, I'm going to go back to one of these original equations. I'm going to use the bottom one. And I'm going to change the y to a negative 3. You're going to get negative 3x. You'll get a positive 12 equals 12. Subtract the 12. Get negative 3x equals 0. So when you divide, x would still be 0. Your ordered pair, 0, comma, negative 3. Once again, I'm going to pause the video, or you can pause the video, work out this next one, and if you solve this correctly, you should have wound up with 0, comma, negative 1. I chose to eliminate our x's. You could have done that at a different number. You also could have chosen to do the y's. But if we both solve it correctly, we should still wind up with the same answer. It also doesn't matter which equation you plug back into. I chose the bottom because I thought it looked more simple than the top one with the 18 involved there. So let's look at our last couple of examples. I know there's at least one thing I want us to see before we're completely done with this lesson. Let's see. The 9 and the 10 would match up at a 90. The 7 and the 9 would match up at a 63. Knowing those multiples can really help. I'm going to go for the 63 then. So I want this to be a 63, and I want this to be a negative 63. So I'm going to multiply the top equation to make my 7 become a 63, which would be times 9. And then I'm going to multiply my second equation to change my negative 9 into a negative 63, and that would be times a positive 7. If we make those calculations, you're going to get negative 81x, positive 63y, and then 9 times 20 is 180. If we do it with the 7, you will get 70x, negative 63y, and negative 70. Hopefully we created this additive inverse relationship that I was looking for. When we add downward, we're going to get negative 11x, we're going to get 0y, and we're going to get positive 110. Since 0y is nothing, we're going to have negative 11x equals 110. We will divide, and you'll get x equals negative 10. Once again, once you find one of those, go to the equation that you think looks more simple to work with. And they're about the same. I'm going to go with the top one this time. And it's going to say negative 9 times my x value, which is negative 10, plus 7y equals 20. And I will solve this. You'll get 90 plus 7y equals 20. Subtract the 90. You will get 7y equals negative 70. Divide, and you will get y equals negative 10. So ordered pair, X goes first, -10. Y goes second, -10. In this case, the order would not have mattered because X and Y were the same value. And in our last example here, we can get the X's to cancel out at 6. We can get the Y's to cancel out at 24. Well, 6 sounds easier, so I'm going to change these to a 6 and a -6 using multiplication. My top equation, I'm going to multiply it by 3. My second equation, I'm going to multiply that by -2. So my top equation becomes 6x minus 24y equals 36. And my second equation becomes -6x plus 24y equals -40. We do have the relationship that we were planning. This will cancel and be 0x. If we do -24y with a positive 24y, those are actually additive inverses as well. And then 36 minus 40 is -4. So if we simplify our left side, we really have 0x's and 0y's, which is a total of 0. And then the right side is still just a -4. We wind up with 0 equals -4. That is not a new situation for us. It's a false statement. And so this system has no solution, which we have now seen in graphing. We have seen it with substitution and now with elimination. If this came out to be a true statement, then it would be infinitely many solutions. It would be implying that the lines are the exact same. If you have any questions, please let me know.